Literally everything, from our DNA to our energy levels. Today, we're putting the spotlight on phosphorus. Just think about that for a second. A full 1% of you isn't muscle or fat or even water. It's a single mineral. So for someone who weighs about 150 pounds, that's like carrying around 1.5 pounds of this stuff. So what exactly is it?
You guessed it, it's phosphorus. It comes in right behind calcium as the most common mineral in your body. And believe me, it is an absolute powerhouse. Understanding how your body handles it is, well, it's fundamental to your health.
So, here's our game plan for this explainer. First, we're going to get to know phosphorus and see what it actually does. Then, we'll dive into the amazing balancing act of its metabolism. And finally, we'll look at what happens when that balance gets thrown off, when levels get way too high or dangerously low. Ready? Let's get into it.
Okay, first things first. Let's get to know this essential building block. What is phosphorus actually doing inside of us all day long?
Well, a huge chunk of its job is structural. As you can see here, a massive 85% of your body's phosphorus is hanging out in your skeleton, teaming up with calcium to keep your bones and teeth strong. The other 15%, that's spread out through all your soft tissues. Yeah, it's in every single one of your cells.
And that 15% is working overtime. Phosphorus is a critical piece of your cell membranes, a building block of your DNA, and it even helps keep your body's pH in check. But maybe its most important job is being part of ATP, adenosine triphosphate. Just think of ATP as the little battery packs that power every single thing your cells do. No P for phosphate, no power. Simple as that.
So, if it's that important, how does the body manage it all? That brings us to the incredible daily balancing act of phosphorus metabolism. It's a constant journey happening inside you right now.
All right, I know this diagram might look a little complicated at first glance, but don't worry. It's really just a roadmap of phosphorus's journey through your body, from the food you eat, through your system, and then back out again. We're going to break it all down.
So let's follow the path. It all starts with your diet. We take in about 1 to 1.5 grams of phosphorus every day, mostly from things like meat, fish, and dairy. Then, your small intestine absorbs most of that, about 0.9 grams. From there, it hits the bloodstream, ready to be used by your bones and cells. And the leftovers? Your kidneys are on cleanup duty. They filter out about 0.7 grams, and the rest leaves your system. It's a really, really efficient process.
Now, this whole system isn't just running on autopilot. You've got this whole team of hormones like parathyroid hormone and vitamin D acting like traffic cops. They're constantly sending signals to your intestines, bones, and kidneys, telling them, hey, absorb more phosphorus, or time to release some from storage, or okay, let's get rid of the excess. It's all about keeping that perfect balance. But sometimes, that delicate balance gets disrupted. If your blood phosphate levels creep up above 1.45 millimoles per liter, that's a condition called hyperphosphatemia. And if they drop below 0.85, that's hypophosphatemia. And trust me, both of these can cause some pretty serious problems. So let's start with what happens when there's too much of a good thing, when there's an overflow of phosphate in the system. That's hyperphosphatemia.
Hyperphosphatemia basically just means there's too much phosphate floating around in your blood, and it usually happens for one of 3 reasons. Either your kidneys aren't filtering it out fast enough, you're taking way too much in, or it's actually leaking out of your cells and into your bloodstream.
Now you can see several causes here, but I want you to focus on the big one, decreased kidney function. By far, the most common reason people have high phosphate levels is because of conditions like chronic kidney disease. I mean, it makes sense, right? If your body's main filtration system is compromised, that excess phosphate has nowhere to go, so it just builds up. And this is why it's so dangerous. A sudden, sharp spike in phosphate can actually cause calcium levels to drop, and that can trigger seizures. But over the long term, chronically high levels lead to something really nasty called soft tissue calcification. This is literally where calcium and phosphate team up and form hard, rock-like deposits in places they should never be, like your blood vessels or even your heart. It can have absolutely devastating consequences.
All right, let's flip the coin and look at the opposite problem. What happens when your body is running on empty? This is hypophosphatemia.
So yeah, hypophosphatemia is the exact opposite, a phosphate deficiency in the blood. And the causes are basically a mirror image of what we just talked about. You're not absorbing enough from your food, phosphate is moving too fast from your blood into your cells, or your kidneys are just getting rid of too much of it. And you might be surprised to hear this is actually a pretty common issue, especially for patients in the hospital. The reasons for it are pretty diverse, as you can see here. On one hand, you've got problems with absorption, maybe from malnutrition or not enough vitamin D. But on the other hand, you could have kidneys that are just in overdrive, flushing out too much phosphate, which can be a side effect of certain drugs or other health conditions.
And how you feel really depends on just how low your levels get. Take a look here. If it's just a mild case, you might not feel anything at all. But as that deficiency gets more moderate, you'll almost certainly start to feel really weak and tired.
And in severe cases, well, this becomes a true medical emergency. A serious deficiency can be life-threatening. Remember those little ATP battery packs we talked about? When your phosphate levels crash, your cells are literally being starved of energy. They're running out of power. And this can lead to severe muscle weakness, confusion, seizures, and even coma, as the body's entire energy supply just grinds to a halt.
So let's do a super quick recap. Phosphorus is absolutely vital. It's essential for our bones, our DNA, and our energy. Our bodies are performing this amazing, complex balancing act every single day to keep its levels just right. But when that balance gets tipped one way or the other, too high or too low, the consequences can be really serious. And that's why understanding and recognizing these disorders is so important. When you really stop and think about it, it's pretty incredible. This whole intricate dance of minerals and hormones is happening inside you right now, this very second, without you even having to think about it. And it kind of leaves you with a final thought, doesn't it? Knowing how important this delicate balance is, what choices can we make to help our body succeed?